Ladies and gentlemen, let's proceed to assist each other. So on my previous video, in one of my videos, I've tried to do a summary of question 3 on paper 2, which is based on the physical properties. So allow me in this one to do a little bit of the summary of question 4, which is based on the types of reactions. So then now as a learner, you need to know that here we are treating 4 different types of reactions. The first one, we've got what we call a combustion reaction. I'm just going to give you the summary of it. We've got combustion reaction. So when dealing with the combustion reaction, as a learner, you need to know that we've got a substance that is burned in the presence of oxygen, so that at the end of the day, that which is produced, it's carbon dioxide and water. Meaning, shortly, when treating a combustion reaction, you've got one substance, one reactant, of which this reactant, it can be an alkane or an alkane, meaning this part of a reactant, it must be what? A hydrocarbon. So on the hydrocarbon, we are adding oxygen, we are adding O2. So on the O2, the O2 that is added, it's going to give you 1 mark as a learner. Then when those two react, then we are expecting 2 products to be produced, of which one of the products, it's carbon dioxide, and the second one is what? It's H2O. So now as a learner, you must be able to balance the equation of which you learned that one in grade 10. And then now, this type of a reaction occurs under certain condition. The first part, we need to do what? We need to have excess oxygen. We must have the excess oxygen. The oxygen must be in excess. Then secondly, we need what? We need heat, because it must be burned. Then we need heat. Those are the 2 conditions for this reaction to occur. Secondly, we've got what we call esterification reaction. So when talking of esterification reaction, it is a reaction whereby a carboxylic acid is reacting with an alcohol, so that at the end of the day, we produce what we call an ester with what? With water. Meaning esterification reaction has 2 reactants, has the carboxylic acid with the what? With the alcohol. And it also have 2 products, which is the ester and then the what? And the H2O, the water. So this ester, they will say to you, is the what? Is the organic molecule or compound. And then the H2O, they will say is the what? Is the inorganic what? Molecule. So then now, for this esterification reaction to occur, there are 2 things that we need. The first part, we need heat, because now we are heating the carboxylic acid with the what? With the alcohol, so that we can form the ester. So we need heat. That's the first thing. Then secondly, we need a catalyst, so that it can speed up the what? The rate of reaction. So the catalyst that we use during esterification is sulfuric acid, which is H2SO4. That's what you need to know with regards to esterification reaction. Ngiyaqhubeka. Thirdly, we have what we call addition reaction. On addition reaction, what is it that is happening? On addition reaction, we need to have an unsaturated compound or unsaturated hydrocarbon. So on the unsaturated hydrocarbon, we need to add something, so that at the end of the day, we destroy the multiple bonds. Remember, when talking of an unsaturated compound, it means it consists of multiple bonds, so that we destroy or break down the multiple bonds, so that at the end of the day, that which is produces a what? It's a saturated compound. That's what is happening. So basic addition reaction, it's about the addition of a molecule on an unsaturated hydrocarbon to form a saturated compound. So then now, this addition reaction, it has 4 types. There are 4 different types of addition reaction. The first one, we've got hydrohalogenation. That's the first one. The second one, we've got halogenation. Then the third one, we've got hydration. The last one, we've got hydrogenation. It means it is made up of how many H's? 4 H's. So bear this in mind. Now, I'll start with the condition. The first 2 H's, hydrohalogenation and halogenation, these ones, they are using, or we need unreactive solvent or no water. These are the 2 conditions, unreactive solvent or no water. These last two H's, then we need to use a what? We need to use a catalyst so that we can speed up the what? The rate of reaction. So then now what is happening on the first H, which is the dehydrohalogenation? For example, if we can take what are we taking? We are taking this compound. It has multiple bonds, this is our compound. It has this double bond. This is the compound having that double bond. We can see that the name of this one is prop -1-N. So the one, it's telling you the position of the of the double bond. So we need to add hydrogen halide. So when talking of a hydrogen halide, we are basically saying this hydrogen, it is bonded with a halogen. Mind you, when talking of halogen, we're talking of those elements that are in what? Group 7 of the periodic table. So what is it that is going to happen? Let me break this down. As we break this down, it's going to be C, the single bond, and then Cl. So at the end of the day, our product, we can all see that this H, this hydrogen, it's going to align itself on this carbon as we destroy the double bond. And again, the Cl, which is the halogen, it's going to align itself on this carbon so that we destroy the multiple bond. So we all can see that our product, it's going to be what? A haloalkane. So meaning we have moved from an alkane into a what? A haloalkane. So this type of an addition reaction is hydrohalogenation. We can even go for HBr, HI, as long as the hydrogen is bonded to a halogen. Then that type of a reaction, then it's added on in the unsaturated compound. It's hydrohalogenation. Then now, for the halogenation, we are adding diatomic halogens. Diatomic halogens are those elements that are found on group 7 of the periodic table. So meaning, if I can again add Br2 on this one, I am adding Br2 on this unsaturated compound. Let's say this one is going to be Br with another one. There's a single bond in between with another Br. So we can see that this Br will align itself on the first carbon, and then this Br again will align itself on the what? On the second carbon. Again, still the product form there, it's a haloalkane. Now, the third type of addition reaction, it's what we call hydration. So hydration, it's basically about the formation of what? Of an alcohol. So it means we need to add water. We need to add water on the unsaturated compound so that we can form what? We can form an alcohol. So since we want to form an alcohol, we can see that this OH, now then it will give us the hydroxyl group, and then we're having this one. So this hydrogen will align itself here, and then this hydroxyl will align itself there, so that we destroy the what? We destroy the multiple bond. So we can see that the product that is going to be formed there, it's a what? It's an alcohol. Mind you, the condition here, I said for hydration, we need to use sulfuric acid as a catalyst, or H2SO4. Then the last one, we are adding H2, hydrogen gas. Then we can say between the particles of the hydrogen gas, we've got single bonds. That's what is happening. So the first hydrogen will align itself on the first carbon, the second one will align itself on the second carbon. So we can see that the product that is going to be formed there, it's an alkane, meaning hydrogenation. We are adding hydrogen gas so that we can form what? We can form an alkane. That is what is happening. Type number 4, we've got what we call elimination reaction. Elimination reaction has three different types. The first one, we've got dehydrohalogenation. I'm going to emphasize on that one. Under the dehydrohalogenation, what is it that is happening? We need to have, what are we having? We need to have, before that, let me explain the part of elimination reaction. On elimination reaction, we are basically having a molecule. Then on the molecule, we need to eliminate something. As we eliminate whatever that we are eliminating, then we need to form what? We need to form multiple bonds. Meaning on elimination reaction, we are moving from what we call saturated molecule to unsaturated what? Unsaturated molecule. So we are having three different types of elimination reaction: dehydrohalogenation, dehydration, and cracking. So I'm gonna deal with the first one, dehydrohalogenation. So on dehydrohalogenation, let's just assume we are having this haloalkane. There it's our haloalkane. So if we want to do or form this thing of the hydrohalogenation, it means we must eliminate the hydrogen halide from the haloalkane. So we all can see that the only thing that we can be able to eliminate here is hydrogen what? Hydrogen bromide. So after we have eliminated the hydrogen bromide, for this type of reaction to occur, we need to have the concentrated strong base. So the concentrated strong base must react with the what? The haloalkane. So examples of concentrated strong base, we're talking of sodium hydroxide, lithium hydroxide, potassium hydroxide. So we are adding, what are we adding? The concentrated strong base. That is what is happening. So most of our learners, they do a mistake here. They don't add the concentrated strong base. Instead, they just eliminate the hydrogen halide and then forming the unsaturated compound with one inorganic compound, of which is wrong. So from the haloalkane, you need to add the concentrated strong base. So elimination reaction deals with heat and concentrated strong base. Those are the conditions. Substitution reaction, it deals with heat with dilute strong base. Concentrated strong base, dilute strong base. So in this case, what is it that is going to happen? As we eliminate this, then we'll be forming the multiple bonds, which is the double bond. Then we'll be forming the double bond here. We can all see that now we have formed the double bond. That is what is happening. This is what is happening. And then now, that which has been eliminated, which is hydrogen bromide in this case, is going to react with the concentrated strong base. So as these two react, they are going to give us two inorganic compounds. The first inorganic compound, we are going to have H2O. We can see we're going to have H2O. That's the first inorganic compound. And then the second one, we are going to have what? Sodium bromide. So this is what is happening during the hydrohalogenation. Like I've been saying, the condition they are heat, of course, with what? Concentrated strong base. Please follow me. On my next video, I'll continue to explain the part of dehydration and cracking and then finish the part of substitution reaction. Thank you for watching.